Hi everyone, today I'll be discussing NAT64. The biggest problem faced by IPv4 is its limited address space. IPv6 resolves this problem by offering a huge address space. And because IPv6 has various advantages such as simplicity, convenience, and high security, it's becoming more widely known. The long-term transition from a network running only IPv4 to one running only IPv6 involves three phases: IPv6 islands, dual stack, and IPv4 islands. During the transition, IPv6 and IPv4 networks coexist. So then, how do IPv6 and IPv4 networks communicate with each other given they have incompatible packet formats? A series of technologies has been developed to enable the transition. A typical one is NAT64, which is used at the later stage of the transition. When an IPv6 user accesses an IPv4 network, a NAT64 device needs to translate the user's IPv6 address into an IPv4 address. This device needs to be deployed at the border of the IPv6 and IPv4 networks. Before address translation, the NAT64 device needs the DNS64 server to resolve the domain name entered by the IPv6 user into a server's IPv4 address, and to send the address information to the IPv6 user, so that IPv4 users can access IPv6 networks. NAT64 also provides the NAT64 server function, which translates IPv4 addresses back into IPv6 addresses. Again, this relies on the help of DNS64 servers. A drawback of NAT64 is that it can translate only the IP addresses in IP packet headers, but cannot translate those in the payload. As many application layer protocol packets also contain IP addresses in their payload, IPv4 devices will consider such packets invalid if these IP addresses are not translated. To resolve this issue, NAT64 ALG is required to translate the IP addresses in the payload of IP packets. However, NAT64 ALG is not compatible with application protocols whose packets are complex or encrypted, such as HTTPS. Because there are many more IPv6 addresses than IPv4 addresses, multiple IPv6 addresses are usually translated into one IPv4 address to allow more addresses to be translated. In this case, if a malicious user uses the post-translated address to initiate an attack, it's difficult to locate the attacker. To address this issue, the NAT64 log function is provided to record the NAT64 data flow information. By checking the pre-translated address information, we can trace network activities and improve network security. Note that to record and store NAT64 logs, we need a log server. In addition to the log function, NAT64 provides other functions to prevent security risks, such as limiting the number of allowable sessions after this function is used. The number of sessions established on a per-user basis is counted. If a specific user establishes more sessions than the preset threshold, this user is blocked from initiating new connections. Without this function, authorized users may fail to establish sessions or access the network, because malicious users may occupy all the session resources by initiating DOS attacks. NAT64 also provides the session aging function to conserve session resources. In addition, it can limit the rate at which user sessions are created. This ensures that other services as well as NAT64 can obtain forwarding resources. To summarize, NAT64 is a major enabler for transitioning from IPv4 to IPv6. However, it still has some limitations. First, in terms of investment, carriers need to introduce dedicated NAT64 devices or service boards and DNS64 servers to use NAT64. The NAT64 device capacity also needs to be expanded as the number of IPv6 users increases. All this is costly. Second, in terms of delay, IP address translation in NAT64 lowers the forwarding efficiency and increases the device processing delay, making it unsuitable for delay-sensitive services. Third, in terms of application layer protocols, NAT64 is not feasible for complex or encrypted protocol packets, such as HTTPS packets. Fourth, in terms of security, the NAT64 log function depends on manual expertise in source tracing, making it difficult to locate an attacker. Transition to IPv6-only networks will resolve all the preceding issues, while NAT64 plays an important role in the transition period. We expect the transition to IPv6-only networks will be a quick process with the help of NAT64.